get straight to the homework, guys. All right, number one. What is number one? It says 9y squared minus 64. That's really a difference of two squares. Let's go to something a little more easy, like this one right here, 4x squared minus 9. That's also a difference of two squares. What do I mean by a difference of two squares? This is a perfect square term. This is a perfect square term. So if you take the square root of 4x squared and you take the square root of 9 and you plug them into your answers, you'll be ready to go. The square root of 4x squared is 2x. The square root of 9 is 3. So you repeat that, 2x and a 3. And since this is not a quadratic trinomial, it's a binomial, that means that there is no middle term. There's only two terms, right? One term right here and another term right there. There is no middle term. So the middle term must have gotten eliminated, and the only way it could get eliminated is if one of them is a plus and one of them is a minus. So that should help you out and get you going for number one. So let's take a look at number one, and let's do number one here. We're just going to set it up into the answer format. Two parentheses right there, a binomial in each one. What is the square root of that perfect square term? That is a 3y. And what's the square root of 64? That is 8. So you have a 3y and an 8. And of course, since there is no middle term, one's a plus, one's a minus. Number two, same exact concept, but what you need to do first before anything is try to pull out what's in common. So on number one, you have a 9 and a 64. There is nothing in common. You can't pull out a y from both terms. You can't pull out a 9, not even a 3 from both terms. There's nothing to pull out. But on number two, you have a 10 and you have 160. So you know you could at least pull out the multiple of 10. So let's do that. Let me pull out the 10. What will I have left on the inside? I'm going to have an x to the fourth and a minus 16, because 160, when you pull out a 10, is 16. 10 times 16 takes you back to 160. Anyway, so right here it gets a little weird because you need to look at the inside of the parentheses and see if you could continue factoring. And once again, you have a perfect square term right here, x to the fourth. That's actually a perfect square term. In other words, you could take the square root of x to the fourth. And you also have a perfect square term right here, 16, which you could take the square root of 16, that's 4. So what we're going to do is just bring down the 10, and we're going to do two parentheses. And the first one, the first term in the first parenthesis is going to be the square root of x to the fourth. And the square root of x to the fourth is x squared. Okay? And when you do the square root of 16, that is 4. And once again, you're going to repeat it, x squared and 4. And you have a plus on one of them and a minus on the other. Okay? Now, this one gets even more interesting because when you zoom in and take a look at this, the first, okay, that's just a 10, but right here, there's nothing to do. You can't factor it. Even though this is a perfect square term, this is a perfect square term, there's a plus sign between it, and that doesn't work out when you try to factor by taking the square roots. Right here, x squared minus 4, this one could be factored even more. Okay, so what I'm going to do is rewrite everything. I'm going to write this 10 that's on the outside, there it is. I'm going to rewrite the x squared plus 4 because we can't do anything with that. But this guy right here, the x squared minus 4, I'm going to rewrite it as a binomial times a binomial. You could also not even think of doing the square roots, but you could even think of it this way. What times what is negative 4? That if you add together gives you the middle number, which is nothing. Oh, well, that'll be a plus 2 and a minus 2. So that's going to be a x plus 2 and a x minus 2. So there's your final factored form answer for that one. Let's go back and let's check out number 3. Now number 3 is a little bit different. A lot of us look at number 3 and probably get confused because we're not used to seeing x to the fourth and the x squared in the middle. But let me ask you this. Let's just go to this problem right here. And would you be able to do that one? Is that one easy? Let's think about this. Well, yeah, it's a quadratic trinomial. And what could he do with quadratic trinomials? He could do the parentheses and start thinking, what times what is the c value that if you combine together gives you the b value? In other words, what times what is 36 that if you combine together gives you negative 13? Well, we know that these guys are going to be x's because x times x is x squared. And what times what is 36 that gives you negative 13 when you combine it? It's a negative 9 times a negative 4. That gives you a positive 36, and when you combine it, it does give you negative 13. And that is the answer if you're trying to factor that problem right there. Okay. However, this other problem over here is almost exactly like it, right? Check it out. You have x squared minus 13x plus 36. Over here we have x to the fourth minus 13x squared plus 36. Same exact values. So all we're going to do is pretend that this is an x squared and this is an x. That's what we're going to do. We're going to pretend. So when I do the parentheses, what belongs as my first term, usually it's an x and an x, but x times x is not x to the fourth. So what do those x's actually have to be? They have to be x squared times x squared. That's the only way it'll give you x to the fourth. And the rest is done exactly the same. All right, you think what times what is positive 36 that if you combine together gives you negative 13? Well, we already know that that's a negative 9 times a negative 4. There we go. Now if we look at numbers 4, 5, 6, 7, on all those we have to factor in some sort of way. On some of these you could pull out the greatest common factor first, right? So like if we just randomly pick, let's go with number 5, I'm sorry. So let's just pick number 5, let's work on number 5. If I do number 5, what could I pull out from each and every term? Well, there's the coefficient 2, the coefficient 6, and the coefficient 80. I know that they're all even numbers. I could pull out a 2. Bless you. I'm just kidding. Get it? Pull out a 2. A 2. All right, forget it. Yeah, so anyways, I could pull out the number 2 from each and every term. I could also pull out some z's. I could pull out a maximum of 4 z's from each and every term. So the GCF on number 5 will be 2z to the fourth. That's what I want to pull out, okay? What's going to be left over on the inside? Well, if I pull out a 2z to the fourth from the first term, I will have z to the fourth, okay? If I pull out a 2z to the fourth from 6z to the sixth, or minus 6z to the sixth, I'm going to have a minus 3z to the second. And last but not least, if I pull out a 2z to the fourth from here, well, it's going to be a negative 40, that's for sure. And there are no z's, because if you pull out a z to the fourth from here, if you take it out, there's not going to be any more z's because you took out the z to the fourth. And again, you don't just stop there. You always have to look further. Look on the inside of the parentheses. Is there anything else that you could do there? Well, if this were a 2 and this were just a regular z instead of a z squared, you could think about factoring, right? Okay, so like if we pretended that this was a 2 and this was a regular z instead of a z squared, we could do this. We would do this. We'd put parenthesis, 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 parenthesis. I would put the z right here and the z right there. And we'd start thinking, okay, what times what is negative 40? But see, you can't have a z right here and a z right here. Why? Because this is not a z squared. What is it? It's a z to the fourth. So what do I need? I need a z squared times a z squared. Because that's the only way I'll get the z to the fourth, right? However, the rest works out the way we used to factor quadratic trinomials, right? The same exact way. What times what is negative 40 that if you combine together is negative 3? So you go through the multiples. 1 times 40, 2 times 20. What times what is 40? 5 times 8. 5 times 8 is the combo that we want. Actually, we want a negative 8 times a positive 5. A negative 8 times a positive 5. Okay. And what about the 2z to the fourth that's out there? Well, you need to put it out there in the front. 2z to the fourth. Okay. So this is your answer. And of course, you're always supposed to look on the inside and see if you could continue factoring. Right here you have z squared minus 8. If that were a z squared minus 9, well then I would go z plus 3, z minus 3, right? But it's not a 9, it's an 8. In other words, I can't really do that, right? So it's not factorable, but you're always supposed to check and see if it's factorable so you could continue factoring. And in this case, you can't continue at all. So this is your final factored form of that original expression. And it looks like we're about out of time, but just to let you know, numbers 4, 5, 6, 7, they're all pretty much the same, like that. You try to pull out what's in common first. On number 6, you could pull out the multiple of 5. Not an x, though. There's not an x in every term. Number 7, you could pull out the multiple of 2. Now, number 8, 9, 10, those are a whole other beast altogether, right? So let's do another video for 7, 8, 9, and 10.